Wearables, tablets, smartphones. Mobile devices have become an increasingly integral part of many people's lives today. At the center of the success of these devices is the abundance of mobile applications, or apps for short. The conventional and most popular method in which apps are developed is the so-called native approach, which usually involves the use of platform-specific languages and development environments. For iOS, this is Objective-C and Swift in Xcode, while Kotlin and Java are used for Android development within Android Studio. This also illustrates the primary drawback of the native approach. Due to differences in platform architectures, apps developed for one platform are usually fixed to that platform. This means that to reach a broad consumer base, developers must maintain separate code bases, one for each platform, with resources divided among each to provide a good user experience. However, this is neither ideal nor efficient. Hence, there have been efforts by the mobile industry to devise methods in which apps can be developed in a cross-platform manner and target multiple platforms from a single code base. A wide variety of techniques have been proposed. In this presentation, we will introduce and outline the primary approaches. Looking down from the top, cross-platform frameworks can be differentiated by the amount of native application elements and whether the framework primarily focuses on generating code or relies on external runtimes. Hybrid, interpreted, and PWA approaches typically rely on the JavaScript engine, while compilation and research-based model-driven approaches focus on creating native code applications. Progressive web applications, or PWAs, are cross-platform web applications defined using the three core technologies of the web: HTML, CSS, and JavaScript. While traditional web apps have been widely accessible on mobile devices, the progressive approach allows for a more native-like experience. Now, we will demonstrate the most prominent features of progressive web applications. This is the game 2048 in the form of a PWA. With a few clicks, the application is installed from the website, bypassing the App Store completely. As you can see, the application icon also becomes available on the home screen. Now, the app can be accessed without the need to launch a browser. Notice that there is no URL box present, which greatly contributes to the native-like experience. Let's now switch off the network and see whether the app will be available offline. As you can see, the game is still playable. The most noticeable advantage of the PWA approach is that apps can be updated without the need to go through a lengthy review process. With a few edits, it is possible to push new versions. Now, it will soon be reflected on the devices of end users. However, the primary disadvantage of this approach is that not all hardware can be accessed. Support is subject to the availability of web standards and corresponding browser implementations. For instance, CanI use reports that NFC is not currently supported by any browser. Another cross-platform technique which makes use of web technologies is the hybrid approach. This technique uses a combination of the web and native methods. From the perspective of the user, a hybrid app is much like a native app. It is installed to the device and is usually distributed via an app store. However, under the hood, UI components are really being rendered by a browser engine, like WebView on Android. This makes it easy for hybrid frameworks to adapt to a multitude of platforms. Unlike PWAs, a hybrid app is able to call native components and capabilities via a JavaScript bridge. This is achieved by effectively encapsulating a web app and plugins within a native app, also known as the wrapper. Command line tools are often provided by frameworks to manage this aspect. For instance, we can use the Cordova command to create projects, manage platforms and plugins, export application packages, and upload apps during development. Here is an example of a hybrid Cordova app with key parts of its source code displayed. Interpretive frameworks use a similar approach and likewise use JavaScript for the business logic. However, you'll notice that the UI is not composed of CSS-styled HTML elements. Instead, These apps use interpreters to generate native UI elements from common JavaScript source code. Compared to web apps and PWAs, perhaps the most powerful advantage of the hybrid and interpreter approaches is their greater support for hardware features. While web apps and PWAs are confined to web APIs, developers are able to employ plugins in hybrid and interpreter frameworks. With the emergence of novel sensors like the EKG, this is more important than ever. Moreover, web apps and PWAs cannot run on or interface with wearable devices. Plugins make this possible for hybrid and interpreted apps. Nonetheless, while the bridging capability of hybrid and interpreted frameworks is powerful, you don't get something for nothing. There is also an impact on performance. Unlike hybrid and interpreted approaches, compilation-based approaches involve compilation, the mapping of source code into native bytecode or high-level representations. Cross-compilation is the predominant approach used by frameworks in this area. With cross-compilers, the framework generates executable code for the target platforms ahead of time. However, when there is no middle layer, the user interface must be redefined for each platform. This is exemplified by the traditional approach of the Xamarin framework, which allows for code sharing but requires platform-independent UI definitions. This aspect is improved upon by later frameworks. Two of the more recent frameworks, Xamarin Forms and Flutter, overcame these limitations by adopting runtime layers. For Xamarin Forms, the method in which the UI is defined is similar to those of interpreted frameworks. With XAML files, of which an example is shown on the right, the definition is shared among platforms. Nevertheless, the distinction remains, as application assemblies are compiled. In contrast, Flutter uses the Skia engine and the declarative approach to render a set of styled but non-native controls. Here, we see a simple app in Flutter. Note the use of Material UI widgets. Now, here is the same app roughly translated into iOS design elements, running on the same emulator. Unfortunately, adding runtime layers also come at a cost. Though the use of runtimes allow developers to define a common UI for all platforms, it also introduces memory and application size overheads. The model-driven approach is simply an extra layer of abstraction over the cross-platform and native approaches. It asks the question, what if we can describe all of the interactions of a mobile application with just models or a domain language? This language can be UML, or a textual language which describes interactions. Some frameworks even use drag-and-drop visualizations. In general, model-driven approaches are really easy to use, as it abstracts away most of the coding. However, the limitation is that it limits your expressive capabilities to what the vendor offers. For example, UI elements may be limited to certain themes and styles. We present a short demo of a model-driven approach. This is Mendix, a model-driven application development system. The backbone of Mendix relies on its own domain language, which, like all domain languages, describes relationships between objects within the model. This model can then be further enhanced by a microflow, which is a semi-visual programming language which describes the steps of more complicated logical operations. After these two steps are completed, a visual drag-and-drop interface of your final application can be created, which can then be tweaked and finally published as either an Android or iOS application. So you might have a question on your mind. Which approach is best? And there is no single answer to this. The best framework invariably depends on the application. For developing an e-commerce app like eBay, progressive web apps may be the primary choice, providing the greatest ease of distribution across platforms. The lack of hardware feature accessibility is not a concern, as it is largely irrelevant for this type of application. Vendors may also appreciate the browser-based mechanism of distribution to potentially engage with more customers. On the other hand, apps which need to interface to novel and innovative hardware features should opt for another approach. Performance requirements are also a factor. The interpreted approach would be a poor choice for an entertainment app involving a lot of video elements, with compilation-based techniques being more suitable. However, hybrid approaches would be a suitable alternative to progressive web apps if conventional App Store distribution is desired. Finally, model-driven frameworks has not seen wide adoption by the industry, and is a niche area in general. This results from a lack of expressive capabilities, as most of the interactions which are possible in model-driven frameworks are dictated by framework vendors.